So we want to talk about acceleration. Plug in my headphone jack before I forget. I said this earlier, but I'll repeat myself. In physics, acceleration is a very key concept. If you know something is accelerating, you know an awful lot about that object. But acceleration in physics, Marley, means speeding up or slowing down. In English, you may say decelerating is slowing down. I'm going to use the term acceleration to mean your velocity is changing. That's all it means. Could be speeding up, could be slowing down, could be changing direction. Acceleration, the official definition, is the rate of velocity change per second. Liam, it's how fast your velocity is changing. A bigger acceleration means you're speeding up or slowing down quicker, more. A smaller acceleration means you're speeding up or slowing down gradually. An acceleration of 0 means you're not speeding up or slowing down. We have a fancy phrase for that. We call that constant velocity. And that's going to be a trigger phrase as we dive into our physics questions that'll almost flash off and on when you read it as kind of a, hey, pay attention. You'll develop that habit. In this section, we're looking at constant acceleration. What does that mean? We can handle stepping on the brakes, we can handle stepping on the gas, but once we've stepped on the brakes or stepped on the gas, we can't push harder. We can't change how hard we're braking. We can't change how much gas we're giving. We can only handle a constant acceleration. For a changing acceleration, Jordan, you need calculus. You need calculus. In Physics 12, we'll look at one specific situation where we have a changing acceleration, but that's where the change is the direction, not the magnitude. The units for acceleration are, well, anytime something is a rate of change, you divide by time. So it's velocity, which is meters per second, divided by time, seconds. It's technically meters per second, but nobody, Amrit, reads it that way, which is why I didn't put it in the blank. The units for acceleration are meters per second squared, because there's two S's down there, and so why would we write two S's when we can just write an S squared? We tend to abbreviate. It is really, really, really worth memorizing what units go with what concepts. Now, again, I said the other day, Camille, you're not going to need to make up flashcards or anything like that, but you want to continually, as we're going through stuff, be reminding yourself what units go with what, because it really cuts down on your thinking. If I see meters per second squared next to a number, it's an acceleration. If I say meters per second next to a number, it's a velocity or a speed, depending on whether they give me direction or not. Acceleration is a vector. It makes a difference whether you're accelerating forwards or backwards. But it's really difficult to visualize and interpret its direction because often we tend to confuse it with velocity. In fact, I guarantee if you take Physics 12 with me, I will give you a thought puzzle and many of you will confuse acceleration and velocity. It's very easy to do. The direction an object is moving at and the rate at which its velocity is changing are both related to the velocity, but not to the acceleration. To determine the direction of the acceleration, we need to watch the object for a while. We're going to do a couple of examples here intuitively, but Jaden writing them out long, and then we're going to ask, is there a shortcut? Okay? So we're going to start at 1.25 meters per second squared east for an acceleration. What would be a more convenient way to write east and west? Even more convenient than E and W.
An arrow?
Even more convenient than that.
No. Oh.
What would be a good way to show west?
Minus.
Negative. Okay, let's do that. Okay. And what I'm going to give you is three different situations where we have three different initial velocities. We're going to gradually get more complicated. So situation A, our initial velocity is 0 meters per second. We're accelerating at positive 1.25 meters per second. Here's what that means. That means every second, my velocity is gaining positive 1.25 meters per second. So if we start at 0, how fast are we going after 1 second? 1.25 meters per second. We're still accelerating. After 2 seconds, how fast are we going? Can you do the math in your head, Parker? 2.5 meters per second. After 3 seconds, how fast are we going? 3.75 meters per second. Pardon me? Not really. It's a slow initial velocity, but if you keep accelerating at that rate for a while, if we could design a rocket that could accelerate like that for, let's say, 3 weeks straight, you run the numbers, you're going crazy fast by the end of that 3 weeks. You're getting to Mars much shorter than our current technology can do. One of NASA's goals right now, somebody was asking me about the EV engine or something like that the other day. It doesn't work, it turns out, but the idea was it gave a very, very tiny acceleration, but it did it with almost no fuel, so you could just keep accelerating for a long time. That would solve most of our space travel issues, but we don't think it's possible. Here's my question. What if I wanted to know your velocity after 500 seconds? Would I need to write out the previous 499 seconds, or is there a shortcut? Please let there be a shortcut. Let's start again, but in situation B, Nick, what's our initial velocity? Can you read it for me right there? What would be a better way to write east? Okay, so now we're going to start off at positive 2 meters per second. And we're accelerating at positive 1.25 meters per second every second. Can I start saying meters per second squared? Because it's just easier to even say, but it does mean meters per second every second. So after 1 second, folks, how fast are we going? No, yeah, 3.25. I'll put the positive now because in a little bit we're going to change signs in the next example, so I'm going to be a bit more careful. And you'll notice meters per second velocity or speed, meters per second squared acceleration, worth memorizing what units are with what. Okay, after 2 seconds, how fast are we going? I'll give you a hint, 4 point something. 4.5? Positive 4.5 meters per second. After 3 seconds, how fast are we going?
5.75.
After 1,000 seconds, how fast are we going? Please don't make me calculate the previous 999 to get there. Ooh, this next one is a bit trickier. Denzel, what's our initial velocity in part C? Keep reading. What would be a clever way to write west? Okay, so now VI, and you know what VI is our abbrev for initial velocity, is negative 2 meters per second backwards. But we're accelerating forwards. So after 1 second, how fast are we traveling? Ooh, yeah. Still traveling backwards, but not as fast. After 2 seconds, how fast are we traveling? I'll even go to 3 sig figs and make it look impressive. Or 2 sig figs at least. By the way, now we're going forward. So here's what else I know, Jaden. Sometime between 1 second and 2 seconds, I went from going backwards to going forward. In fact, I can even be more specific. Sometime between here and here, there must have been a very brief moment where I was stopped. I was going backwards, slowing down. In fact, if I mime this out with my office chair, that's backwards, that's forwards. I was going really fast, slowing down, and then I started going forwards. And you can see the only way that I can start speeding up forwards is there had to have been a brief moment there where I was stopped. Had to have been. Ooh, after 3 seconds, how fast are we going? Matt?
1.75.
Positive 1.75 meters per second. And I wrote, there has to be a better way to do this. Please let there be an equation. And there is. There is. Yeah.
For number A, or letter A, you
Yeah.
said that if you kept that pace up for 2 weeks, you'd go really fast.
Pretty fast, I think. Yeah.
You'd be going 1,512,000
Yeah.
meters a second.
Is it? I'll have to check your numbers, but yeah. Like, don't kid yourself. It's, by the way, in rocketry, it's not about the speed. It's about your acceleration. If you can get your acceleration going to something, in fact, the ideal would be if you can get the acceleration to exactly match gravity, which you'll learn later. This unit is 9.8 meters per second squared. If you jump out of an airplane, I mentioned I jumped out of an airplane. I jumped out of an airplane. If you jump out of an airplane, in free fall, you're accelerating to the Earth at 9.8 meters per second squared. So if you had a rocket ship accelerating forwards, you would feel exactly fake gravity of Earth. But the fuel to do that would be cray. But also, if you run the numbers, wow, you'd get to Mars really quick. If you could accelerate at 9.8 meters per second halfway there, spin your rocket ship around, and then start accelerating backwards to slow down, each way you would feel artificial gravity, which would deal with a lot of the muscle atrophy and everything, but the fuel is crazy. Yes?
Where did you start it?
Patience, you'll see a video in a few days. That's called a teaser, my friend, a preview of coming attractions. We will do a lesson on free fall. Of course we will. So, you might recall that I said acceleration was the rate at which the velocity changes. We have a symbol for change in. It's delta v over delta t, but the v should technically have a vector sign above it because you're going to have to pay attention this year to positives and negatives. We'll decide, Liam, that forward is positive and backward is, up is positive and down is, yeah. Physics 12 will start moving at angles, and then you have to do vector math. But for now, Physics 11, we'll just keep it simple, positive and negative. Oh, I didn't put a vector sign above time because time is a scalar. What's change in anything from your green sheet, front page, probably first row? So on the top, this is really V final minus V initial. On the bottom, technically, I should go time final minus time initial, but I think I said the other day, we get lazy and sloppy with our time notation. To measure time, you always have to start initial and stop final. A stopwatch. Thank you. Time by definition has to be a change in, and so we're lazy. We just don't bother putting the delta in front of it. It's kind of an understood one. This is our equation for acceleration. If I write this in math speak down below here, A vector equals V final vector minus V initial vector over time. A little note. Change in anything is always final. My abbrev for final will be a lowercase f subscript minus initial. My abbrev for initial will be a lowercase I. So you'll see an awful lot of that minus, and because an I from the back of the room looks like a 1, I'll always put a little curly little thingy on the I there. Yeah.
Could we just do a capital I? Or
No. Capital I is current, means something totally different. Have I mentioned that we don't have enough letters? We don't have enough letters in our English language to go around. We got 26 times 2. We have to use them very meticulously to be organized. Okay. Symbol for acceleration then is lowercase a, not uppercase. Uppercase A is area and something else. The units, well, it would be meters per second, meters per second squared. And who remembers, is acceleration a scalar or a vector?
It is a vector.
Because it matters whether you're accelerating forwards or backwards. That will change the outcome.
Yep.
Velocity has the same symbol as speed, which is v. If the velocity at the start of the time interval is vi, the end is vf, the change in is vf minus v. I just said all that quickly, so I'm not going to read that whole paragraph. But this is our first big equation right here. How many letters are there in that equation? How many variables? There's 4. A, VF, VI, T, which means how many different equations are hidden in there? Same answer, 4. You can memorize all 4 of them, or I will, starting today, teach you how to rewrite and derive them in your head, and thereby cut down on your memorization by like 90%. It's worth learning how to rewrite them. It's going to seem a little weird at first, but trust me, it's well worth learning that skill. I wrote here, since velocity has 2 aspects, speed and direction, because it's a vector, acceleration can change if speed changes. That's the one most of you are used to when you're hitting the brakes or stepping on the gas. If direction changes, going around a corner, you are accelerating. Or both, speed and direction change. Going around a corner while stepping on the brakes or going around the corner while hitting the gas. In this unit, we'll be mostly looking at this one. In Physics 12, we'll do an entire unit where we look at that one. Rarely will we look at both. That's when you need calculus. Example 2. This is our first officially kind of physics-y word problem. It says this: a runner accelerates from rest to a speed of 9 meters per second in 4.5 seconds. What was his average acceleration during this time interval? I want to give you a hook, a method, something that you can do when you don't know what to do. And my hook, which we're going to write out in our notes later, is something that I've already alluded to. I call it DFIC. First thing I always do is I list my data. More specific, Malcolm, what's this question asking me to find? One of the things I like about physics word problems versus the stupid ones they make you do in your math class is it's pretty easy to figure out what they're asking you to find, because it'll almost always be what is the, or find the blank. And what I'm going to write then is this: A equals question mark. That's my way of saying I figured out what they want me to find. But also, Ronan, the question is no longer blank. I'm more relaxed. I feel better. I'm going to be more successful. Now I go through the question and I'm looking for numbers and physics words. What's the first number, Jaden, that you see in this question? Yeah. What's the first number you see? 9. What are the units next to the 9? It's a velocity. Has to be. Here's the question. Is that my initial starting velocity or my later on final velocity? VF equals 9.
You put 9s in all your examples so you can make that go.
9. Yeah? Did I have that one set up, wondering if some kid would ask it?
Probably 9. Yeah.
What's that 4.5? Yeah? How do you know time? And you'll notice I didn't use the word time in front of this, and I could even have said from rest to 9 meters per second without the word speed, but if you see the meters per second, you can figure out it's a velocity. So T, problem, I need VI. You notice I said earlier, I look for numbers and physics words. Here is your first physics word, and this is a good one to get in the habit of always underlining. Can everybody underline from rest? What's VI as a number exactly? Sorry? 0.
Meters per second.
Now, Matt said the units, and if you put the units, I will not take marks off. But what I tend to do, because I'm lazy but organized, as I write stuff out, I'm checking the units. So as soon as I wrote meters per second, I said everything else has to be in meters, and I'm scanning seconds, check, I'm good with that. 0, no, I'm good with that. Had anything else been wonky, I would have gone back and added my units in, ding, 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 because I'm going to have to do some conversions. Thankfully, we just wrote a test on that. I'm looking for an equation that has an A, a VF, a T, and a VI in it. You only have one right now. It's this one. Write it out. You'll notice I got a bit sloppy. I didn't put the vector signs in. You can if you want to. During your work, I won't be fussy. On your final committed answers, I might be fussy, and I'll show you what I mean by that later. The arrow, no, they're not all vectors. Time is a scalar. Time will not be negative. If you ever get a negative time on your calculator, you've messed up. Go check. You've done something wonky. I get 9 minus 0 divided by 4.5, and I can do this in my head. It ends up being 2.0 even, yes?
Yeah.
Meters per second squared. Is that a big acceleration? Right now, you don't have a good context for what's big and what's not. We'll do a lesson where we talk about what 1g is and what human beings can handle, but I haven't got there yet. Yes?
Any finite zone has to do 1 meters per second squared
Or meters per... Well, meters per second would be wrong. That's a velocity. If you said meters per second, I'd take that, but I'd also say, you're writing extra. Meters per second squared is the correct units for acceleration. Now, if we wanted to add a direction, but if you don't write a plus sign, I kind of know it's a positive number. If you know they were slowing down, you should have got a negative answer if you set it up right, and you would definitely put the negative in front. Yeah?
Just for context, is that fast?
No. For a sprinter, well, what's Usain Bolt's world record for running 100 meters? So VI is 0, any race that I've watched. You don't know VF, you know the distance, 100 meters, you know time. It'd be cool if we could figure an acceleration out from that next lesson. And then you would know that, by the way, that would be Usain's average acceleration. I've watched runners, they don't accelerate constantly, and we can't handle that changing acceleration, but you would be able to calculate Usain's average acceleration and compare it to this. Yes? Put all your answers to 2 or 3 sig figs. In fact, I'll almost always go to 3, unless there's a bunch of zeros like this. So, next page. The standard SI unit for expressing acceleration is meters per second squared. An object is accelerating at a rate of 1 meter per second squared if its speed is increasing at 1 meter per second each second. In other words, if your acceleration is 1, every second your speed goes up by 1. If your acceleration is 5 meters per second squared, every second your speed is increasing by 5. If your acceleration is negative 5 meters per second squared, every second your speed is decreasing by 5. But we'd rather come up with an equation that could handle all that thinking for us. A UFO is reported as accelerating from rest. Stop. Everybody underline the phrase from rest. To 680 kilometers per hour in a time of 2 seconds. Why is an alarm bell going off with me already? Can you see it? Yeah? I'm going to have to do a unit conversion. Okay, I picked it up.
Write down
what is its acceleration? First of all, before I write down what they gave me, Matt, what are they asking me to find?
What is its acceleration?
A equals question mark? From rest. What's that tell me?
0.
What's 0? Which one? VI is 0. And you can say VI and VF. We'll just start getting familiar with those abbreves. We'll even say them that way out loud. Okay. What's that 680? I know it's a speed or a velocity. By the way, technically we're finding speeds here. We're not getting but whatever. 680 kilometers per hour. I need to do a conversion. How do I convert kilometers per hour to meters per second? It's something to do with a 3.6. I don't know. I put it on my sheet so I wouldn't have to memorize.
Yeah.
And this is that lesson where I totally botched it and read it the wrong way, and I'm honestly embarrassed enough I didn't put that lesson on YouTube, and I almost never do that, partly because I didn't want to lead my YouTube leaders astray and I couldn't figure out how to change it on YouTube. So I think it's divide by 3.6, yes?
Yes.
So how many meters per second is that? Get your calculators out.
188.88.
188.8 repeating. I'm going to write 189, but I'm going to store this on my calculator.
Store. Don't clear.
What's that 2? I'm looking for an equation that has an A, a VI, a VF, and a T in it. And the reason I'm saying that phrase is starting next class, you'll have 4 different equations to pick from, and you'll have to identify which one we're going to use. In this case, we only have one. It's A equals VF minus VI over T. I'm going to write 189, but I'm going to hit my answer button here. And if you don't know where your answer button is, you want to figure out where it is today, because we're going to use that button a lot. It's less typing, it's more accurate, and it's less error. That's the only triple win on a calculator I know of, so we'll use that. Minus 0 all over 2. So, couple of notes here. Is this a fraction? Is there more than one thing on the top? Well, I can sort of ignore the 0, but just to get you in the good habit, the fact that this is a fraction, if you have one of the fancy schmancy fraction buttons, you would want to hit that, or technically I should put the top in brackets because there's more than one thing on the top, except minus 0 won't make a difference. Divided by, is there more than one thing on the bottom?
No.
On one of your test questions, there was a fraction with more than one thing on the bottom, and a lot of you got that one wrong because you didn't put the bottom in brackets. We'll talk about that next class. Oh, wait a minute. I'm not going to go 189. What button did I say I was going to use?
Answer.
So I should go answer button. If you can't find your answer button, now is the time to ask, and I'll show you where it is. Anybody not be able to find it? Okay. Minus 0, close bracket, divided by 2. If you use your answer button, you'll get 94.4 repeating. If you use 189, you'd probably get 94.5, and you've now introduced a little bit of error into the rest of your calculations if this was a multi-step question. So get used to using your answer button. Yes?
In the setting, could you just completely ignore the step when you have the minus 0 there and just go 189?
Yep. But here's what I would say. First of all, I will teach you a lot of shortcuts that I encourage you to use in your homework. On a test, I tend to write everything out because I've often made dumb mistakes. I will even go 3 plus 2 on my calculator on a test because the number of times I've gone 3 plus 2 equals 6 in my head because my brain multiplied. So you'll see in homework, I will try and do math in my head. On a test or a quiz, I'll show every step just to make sure I don't make a dumb mistake. What's the mistake I've made right now? Can you see it?
Yeah.
Yeah, what? Good. I could go work for Verizon. And the positive means forwards. Is that a big acceleration? Yeah, that's about 9 Gs.
That's too much.
Okay? Human beings above 10 Gs, we tend to start breaking bones. Above 25 Gs, we tend to start not coming home. Okay? That tends to be fatal. It all depends on what angle you absorb the G's at, but generally above 25 G's, really bad things are happening.
Just do like Roman's pressing
We'll do a whole lesson on G's, but keep that thought.
Jeez Louise.
Remember I said that equation had 4 variables, which means there's 4 ways to write the acceleration equation. One way would be to get the VF by itself. So let's write down A equals VF minus VI over T. I'm going to leave the vector signs off right now because I'm just going to do formula manipulation and they're going to clutter things up. What's the T doing on the right-hand side? Mathematically, what's the T doing on the right-hand side? Dividing everything on the right is the same as cross out the T, multiplying everything on the left. So another equation is AT equals VF minus VI. That's the same equation as the one in the box, just looks different. I'd like to get the VF by itself. What side is the VF on, the left side or the right side? What side is the VF on, the left side or the right side?
Right.
Right side. What else is on the same side as the VF? A minus VI. How could I move a minus VI over to the other side?
Add it to the other side. all alone.
Although we typically put the thing that's by itself on the left. So instead of VI plus AT equals VF, I'm going to write VF equals VI plus AT. This is actually the equation that we'll use the most because it doesn't have fractions. And most of you fractions are the math F word, not the F word you're thinking of. Okay. Oh, from this equation right here, I could get the VI by itself. What side of the equation is the VI on? What else is on the same side as the VI? A plus AT. How would you move a plus AT over to the other side?
Minus 18.
So yet another equation would be VF minus AT equals, well, you know what? Instead of writing equals VI, do you mind? Can I put the VI equals on that side? Because that's where we're used to seeing the thing by itself. By Thursday, about 80% of you will be doing all this in your head without writing anything down. By the following Friday, almost all of you will be doing far more complicated than this in your head without writing anything down. If I can get you there, I've cut down on your memorization by like 90%. And it's also kind of geekily satisfying to rewrite stuff and do a bunch of complicated stuff here and go straight to 2 lines and you're done. There is the inner nerd that we all possess that says, that's kind of cool. Ooh, how would I get the T by itself?
Multiply and then minus 8.
Multiply what and then what? First of all, which equation am I going to start with? This one?
Very, very first.
Here?
Yeah, that one.
Okay, so you're saying, let's write it out. A equals VF minus VI over T. Talk me through it.
So you're gonna take, what do you do when something's on the bottom of a fraction?
I don't know, what do you do?
You multiply it against the other side.
Okay, so dividing by T on the right, same as timesing by T on the left.
It's the exact same.
And so that would give me,
18.
I want to get the T by itself.
Well, how are you gonna do that?
I don't know, how am I?
You're gonna add the A to the other side. I mean, subtract the A to the other side.
Strike
I
2.
made it dumb and straight.
Well, what's the A, what? Why divide the A?
That's right.
And since the A is multiplying the whole left side, it better divide the whole right side. Here is an equation for time. And now that I've rewritten the equations, now I'll put the vector symbols in and make it look pretty. So boom, 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 no vector on time. Boom, 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 no vector on time. So let's talk a bit more about acceleration. All of us have a built-in accelerometer. You can feel acceleration. You can feel, even with your eyes closed, whether you're speeding up or slowing down. Here's the only problem. Your built-in accelerometer works backwards. Whatever way you feel like you're getting pushed, the acceleration is the opposite direction, I guarantee it. Let me give you an example. When a car is stopped at a red light and a driver stomps on the gas, which way do you feel like you're getting pressed?
Backward.
But which way is the car clearly accelerating?
Forward. Why is that happening?
Can you hold that question for a couple lessons?
Yes.
A couple lessons.
That's so many.
Yeah.
Earlier you said that there's no way you can, like, if a car's rolling backwards and it can go forward, what if you had, like, a rock out there and it just, like, was rolling backwards super slow and it just
It still
wouldn't
stops.
stop?
Can you, sorry, earlier I said what exactly?
That you can't go, if you're rolling backwards, you can't go forward without a period that you're completely stopped. But what if there's, like, a giant...
There would still be a momentary brief pause, change in direction. Now, in calculus, we can say mathematically, we can posit an instantaneous change in direction, and you can show that mathematically. But the problem is that would happen so fast. No, the problem would be for that to happen, time would be 0. Can you divide by 0? Problem. No, we got to work around it. Calculus has a workaround, but it's a calculus workaround. Nope. Limits. B,
Oh, I did that.
when a car hits the brakes and stops quickly, which way do you feel like you're being thrown? Forwards, but you're slowing down, you're accelerating backwards. Your body is a backwards accelerometer. You can feel it, but it's always in the opposite direction that you feel acceleration. Always. I haven't yet found a situation where you can't use that. How many of you have been on the elevator before? At Playland? Okay. When it shoots you up, clearly, which way are you accelerating? Which way does your stomach feel like you're being pressed? Yeah.
Downward. Now it's a y-axis.
Oh, and by the way, once you're at the top and the elevator shoots you down, you're clearly accelerating which way? Downwards. But which way does your body feel like it's about to fly?
Line up.
Okay? So you feel like you're getting pushed up. That works. I have yet to find a single situation where the idea that the direction of the acceleration is the opposite of what you feel. So if you ever are asked, which way is the acceleration? If you can imagine your body sitting in that vehicle or ride or whatever, and you know which way you're getting pushed, it's the opposite direction, I guarantee it. Oh, there's a ride at Playland called the Music Express. It's right near the pirate ship. That's the one that goes in a circle really fast, and then the DJ says, who wants to go faster? No, where you go? It goes really, really fast. When you're going really, really fast in a circle, which way do you feel like you're getting pushed? Outwards. Which way are you accelerating? Which way are you accelerating? Inwards. Yeah. Yeah, it is. Someone asked, why is that? The reason is inside your body, you're mostly liquid. And actually what your nerves are feeling is the liquid sloshing inside your body. Okay? And the liquid wants to stay where it is. Your skin has to accelerate forwards. The liquid stayed where it was. And so the liquid sloshes against the back of your body, let's say. But you think, oh, I must be getting pressed backwards because you're not used to having your inner liquid slosh around.
Would you also feel that if you were just free falling out of a plane?
No, free falling is tame. I'll talk about that more when I do my free fall lesson. I'll show you a bit of me jumping out of an airplane. Eventually I jumped out of an airplane. Example 4. Example 4. Read example 4 to yourself.
Example 4.
What 2 words should I underline?
Are rest, from rest,
Okay.
and
And here's the question. What's example 4 asking me to find? More specific. In terms of the 4 physicsy concepts that we've talked about today in our equation, what's it asking me to find? Someone has said how fast twice now, but in terms of physics terminology, how do I know it's not asking me to find acceleration?
because it's asking you how
It gave it to me. Don't circle that, but I see a meters per second squared. I crossed that off. I'm not finding that. How do I know they're not asking me to find time?
Oh, velocity.
Which one?
Final velocity.
VF equals question mark.
Oh, you're smart, part Sharky.
Okay.
No, we said loud.
What's that 4.5?
Meter per second squared.
So what is it?
It's the acceleration.
Yep. What's that 3.6?
Time. What's it?
What you're going to notice in this unit is you need 3 things to find the 4th thing. Right now I only have 2. That means the question must have told me something else. What did I underline and what does that tell me?
Rest. Oh, 0.
I'm looking for an equation that has a VF, an A, a VI, and a T in it. There is one.
Wait, we know that one.
Do we?
It's like we found this.
Did we? What's the equation for VF?
I don't know.
I don't think it's VF equals VI minus AT.
It's VF.
Minus A over T.
No.
VF.
Now, you ready? Look at your green sheet, please. Second line, first equation. So on that line, I think it's the second line. Does the second line say VF equals VI plus AT, or is that the third line? And on that second line, there are 4 equations in a row, I think.
Yeah.
Those are the 4 kinematics equations that we're going to look at starting tomorrow. but VF equals VI plus AT. You'll probably, most of my kids end up memorizing this one because they get sick of looking it up because you use it so often. And that's the only reason you should memorize something, because you get sick of looking it up because you use it so often, but you don't need to. This is nice because I got the VF by itself. What was VI?
0.
Plus,
Uh,
are my units all okay?
yeah.
Yeah.
I did a quick check as I was reading.
4.5 times 3.6.
Which is what?
16.
16.2? Is that what somebody said?
Yeah.
Units. Direction, well, positive, so forwards. So again, we're going to be a bit sloppy this year. We're not going to write forwards. I'll assume positive means forwards. But if it's backwards, make sure you tell me it's negative. Okay? Is it 16.2? You all try it on your calculator? You want to follow along? Okay? Marley, question? You sure? This might be a good one. Okay? I will sometimes deliberately leave a step out to try and get someone to ask a question. I've done these lessons long enough. You may notice I'm pretty good at predicting where we're heading because I've done this for a while. I like example 5. I like example 5. I like example 5. Example 5 is a nice question.
Must be on the test.
Ronan,
Question.
answer.
Is there a different way you can write a plus sign? Because I always think it's a T.
I know that I'm not a fan of this division sign. Here's what I will do. I don't change the plus sign, but I will always write my T's with a little curly. Okay? And you'll see me do that all the time. This T has one. Even if it's not very big, I'll always put a little curly on the T. Hey, Ronan, what's example 5 asking me to find?
It is.
Yeah. It's okay.
You define 5
How do you know?
because it says how many seconds.
This is why I'm telling you it's worth memorizing what units go with what concepts. It really is. So I'm going to write down T equals question mark. What's yucky about this question? Yeah? Okay, so you ready? Let's read through this, looking for physics numbers and physics words. What's that 110? VI? 110 kilometers per hour. And I'm now going to put divide by 3.6 equals 110 divided by 3.6. Okay, 110 is freeway speed, especially out in the Coquihalla area. So I get 30.55 repeating. I'm going to write 30.6, but I'm just going to keep this on my calculator. Okay. What's V final? Why can't that possibly be V final?
That's fine.
Because it says meters per second squared. So what's V final? How do you know 0? Okay, another physics word we should probably look for. So the two ones, from rest is when VI is 0, or comes to a stop or comes to rest. Those are phrases you want to start training your brain to look for. For the first while, we'll underline them. In a couple of weeks, we'll stop physically underline them because, Jaden, your brain will just underline them mentally anyways. So VF is 0. What's A? For a candy, who can tell me why writing this is wrong? A is not 8.
Meters.
Nope. This is why I like this question. This is why I like this question. This is why I like this question.
Because you're trying to find time in
Nope.
seconds.
A can't be 8. Okay, so here's the beauty. All of us have made a subtle mistake. But the nice thing is, the universe is about to tap us on the shoulder and tell us we've made a mistake. I'm looking for an equation that has a T, a VI, a VF, and an A in it. There is one.
T equals.
I got that part, Captain Obvious. That's good.
Yeah.
My bad. VF minus VI over A.
What was VF? 0 minus, I'm going to write 30.6. I'm going to use my answer button all over 8 Everybody get your calculator out. Follow along with me, please. Is this a fraction? Yeah? If you have the fancy schmancy fraction button, 2 levels, hit that. The rest of us, we're going to have to open up a bracket because there is more than one thing on the top. 0 minus, and then hit your answer button, divided by 8. Why must this be wrong? What do you get?
It's negative.
Time can't be negative. So the universe is tapping you on the shoulder and saying, you've made a mistake somewhere. For a candy, where have we made our mistake?
Meters per second squared.
Yeah, what?
What?
Oh, wrap it up right now.
No. It's negative.
What's negative?
Because
What's negative?
meters per second, because you're
Are we slowing down?
We're slowing down.
Oh, son of a gun.
Oh, you got us, Matthew.
Son of a...
But here's the beauty. I hope all of you would have looked at that answer and kind of frowned and gone, wait a minute. Duick said time has to be positive. Time has to be positive. The universe will tap you on the shoulder occasionally and say, go check your notes. Go check your work. You've made a mistake somewhere. Okay? So I didn't hit equals on purpose. I'm going to go divided by -8. And so you all got the correct magnitude for time, but that won't always work. So all of you had a -3.81. That you might actually have a completely different answer if you get a negative time. So go back and check and redo the question. But is it 3.82? Yep.
on most calculators, if you like did it wrong,
Yeah.
that would then change the answer button to go back to
You got to start from scratch. Yep. Yeah, so that would change your answer button. In other words, now what you'll have to do is once again go 110 divided by 3.6, store that on your calculator, and then go 0 minus answer button divided by -8, and now you will get the correct answer. So one of the nice things I do like about physics, and I will teach you built-in error checks. You'll often hear me say, hey, there's a built-in error check on this question. The answer can't possibly be this. If you get that, you've messed up. It's a little nicer than math word problems where you really have no idea what the answer is supposed to be. Example 6. Anybody here have a Tesla? Nice. I've taken one for a test drive. These numbers are reasonably accurate. So the Tesla Model X SUV can accelerate from rest to 30 meters per second in 3.2 seconds. What's this question want me to find, Amrit? You were zoning out, that's why I brought you in. What's this question want me to find? Let's write down A equals question mark. What 2 words should I have underlined? Dunk. Amrit, what does from rest tell me? What, oh, VI? What is it? Yep. What's that 30? How do I know that's not time? Meters per second. Like even if there was no words, I would still know not time. Because meters per second. What's that 3.2, Amrit? I'm looking for an equation that has an A, a VI, a VF, and a T in it. There is one. A equals VF minus VI over T. The one that we started this lesson with. Acceleration is change in velocity over time. Technically, vector, 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 and time is a scalar. Amrit, what was VF? Oh, I forgot to write the number. I just wrote the units, silly me. Give myself more room.
Everyone makes silly mistakes.
I make more than most.
Well, mistakes are how you learn. So that means you have to roll solve.
There you go. So it's going to be 30 minus 0 divided by 3.2. Can I do that in my head, Mr. Duick? Maybe. That's going to be 30 divided by 2 is 15, divided by 2 is 7.5, divided by 2 is 3.75, divided by 2 is going to be, nope. I need a calculator. Brackets around the top because there's more than one thing on the top.
1.47.
Don't need brackets around the bottom. 9.38? 9.38?
I think so.
Units, it's an acceleration. Meters per second squared. And you'll notice often I put a box around my answer. That's part of my routine. I put the units on, I put a box. That's my way of saying the same way people spike a football after a touchdown or raise their hands in the Olympics after winning a medal. This is my done. Okay? That's my touchdown little dance.
Win.
What's your homework?
Finish this page.
You can try every question on this page. You probably want to do these on a separate piece of paper. I didn't leave you enough room. I did give you the answers. However, you can cross out 1A. I didn't like that. I should have changed that one. And you can cross out 2. Oh, no. Never mind. I like 2. I'm sorry. If you didn't if you crossed it out, I apologize. Try and read it and do it. Okay, 2, you have to do a unit conversion. I'm okay with that. 3 is good. Oh, hey, there's Usain. Somebody asked me Usain Bolt. I thought I'd looked up his numbers. So those are his numbers. Okay. Number 5. All of these questions are good. Yep, there's more. You're gonna get some time though.
So many meters per second.
Okay. I have not done every specific type of example in the homework in your lesson. I want you to have the aha moment occasionally. Otherwise, absolutely, next class you can ask me questions from the homework.